I'm Eng Tiong Jia. Hi everyone, I'm Eng Tiong Jia, MVP for Developer Technologies. I'm going to share about scaling Git for Enterprise DevOps. First, about mono versus multi repos. A repository is simply a place where the history of your work is stored. It often lies in the .git subdirectory of your working copy. So, what the best way to organize your code repository? Software development team start off with the best intention to keep clear separation concern in both the software development and their code repository. However, over time it is not uncommon for the code repository to be flooded with unrelated code and artifacts. There are two philosophies on how to organize your repos: mono repos or multi repos. Mono repos are a source control pattern where all of the source code is kept in a single repository. This made it super simple to get all your employee access to everything is one shot. Just clone it down and done. Multi-repos, on the other hand, refer to organizing your project each into their own separate repository. The fundamental difference between the monorepo and multi-repo philosophies boil down to a difference about what allows teams working together on a system to go faster. The multi-repos view is a extreme form. It is that if you let every sub-team live in its own repo, they have a flexibility to work in their area however they want, using whatever library tools development work for actually will maximize their productivity. The cost obviously is that anything not developed within a given repo has to be consumed as if it is third-party library of service, even if it was written by the person sitting on desk over. If you find a bug in, say, library you use, you have to fix it in the appropriate repo, get a new artifact published, and then go back to your own repo to make the change to your code. In the other repos, you have to deal with not only different code base but potentially with a different library and tools or even different workflow. Or maybe you just have to ask someone who owns the system to make the change for you and wait for them to get around to it. The mono repo review, on the other hand, is that a friction, especially when dealing with more complicated dependency graph is much more costly than a multi-repos of advocates recognize, and that the portability gains we had to be had. Letting different teams go their own way aren't really all that significant. Wow! It may be a case that some teams will find a locally optimal way of working. It is also likely that their gains will be offset by other teams. Choose a suboptimal way of working. By putting all your eggs in the one basket of the monorepo, you can then afford to invest in watching the basket carefully. Clearly, the frictions have to make changes in other repos, or worse, having to wait other teams to make changes for you is largely avoided in monorepo because anyone can change anything. If you find a bug in library, you can fix it and get on with your life with no more frictions than it if you have found a bug in your old code. GitHooks. Why care about GitHooks? Continuous delivery demands a significant level of automation. You can be continuous delivery if you don't have a quality code base. This is where Git fares so well. It gives you the ability to automate most of the chat in your code base even before committing the code into your local repository, let alone the remote. GitHooks are mechanisms that allow arbitrary code to be run before or after certain Git lifecycle event occur. For example, one could have a hook into a commit message event to validate that the commit message structure follows the recommended format. The hook can be any sort of executable code, including Shell, PowerShell, Python, or any other script. Or they may be a binary executable, anything goes. The only one criteria is that hooks must be stored in the .git hooks folder in the repo root, and that there must be named to match the corresponding events. Apply mass message pre-apply patch, post apply match pre-commit, prepare commit message, post commit, pre-replace, post checkout, post merge, pre-receive update, post receive, post update, pre-auto, post and rewrite and pre-push. The Git version is a tool to help you to achieve semantic versioning of your project. The goal of adding a new dependency to your code to avoid reinventing the wheel. If there is a code already available that does what you want, normally you would prefer to reuse, and there are other exceptions rather than investing your time rewriting a code to solve the same task. On the other hand, once your software project has matured over time and is ready for production, it may end up being a dependency for other software projects as well. Initially, reusing a software package as much as possible look like the best way to forward save time and effort in the long run. However, creating dependency with other software packages also brings its own disadvantage, especially where the number of dependencies becomes larger and larger. Grouping of the shell function into a software package and defining dependency between them has been traditional at the core of software development. If you are building library, product or any other software system, versioning is usually pretty big deals. The only ways to determine what version of the library, product or system you are looking at before an organization settles on a versioning strategy. Many discussion has been held on what constitutes a major release versus a minor release, how to version the component from a marketing perspective, and how deal with bugs with. In addition to that, if that software system involves a library framework or just component, then you will be pretty interested to know when update that component involves breaking changes. From the versions, an app you should, for instance, be able to guess whether it's a bug fix or it has introduced a feature so we are properly set versions of code. So you could totally lose your compass on what's happening. So when you set a version of your software, always be careful. Remember that given a major, minor patch version number, you should increment patch when you make a bug fix, minor when you introduce fixes, major when you make changes that break backwards compatibility or completely changes the user experience. That being said, in the daily practice, if you want to start with a development phase before going to a production, the simplest things could start with a 0.1.0 version number and increment minor at each new development release. Also keep in mind, if you are working on a production project, it's always a good idea to start with the 1.00 version code. Public project. An Azure DevOps offers a suite of DevOps capability to develop, including a source control, agile planning, build, release, and more. But use a Azure DevOps feature requires users to first log in using a Microsoft account. This however brought the interesting scenario where you would want to share your code that artifact publicly or simply provide a wiki library or build a status page for unauthorized users. With a public project, users will be able to mark Azure DevOps team project as a public. This will enable anonymous users to be able to view the content the project in the read-only stage, enabling collaboration with anonymous and authenticated users that wasn't possible before. Anonymous users will largely see the same view authenticated users with non-functioning such as setting or actions such as queue view, hidden or disabled. Public versus private project. Project in the Azure DevOps provides a repository, the source code, and a place for a group of developers and a team plan, track progress, and collaborate on building software solutions. One or more projects can be defined within an organization in Azure DevOps. Users that are just signed into a service have read-only access. Public project on Azure DevOps private project, on the other hand, require users to be granted access the project signed into access service. Supported service. No member of a public project will have read-only access to a limited set of a service, specifically browse the code base, download code, view commit, branches, and pull requests. View and filter works item, view a project page or a dashboard, view the project wiki, perform semantic search of the code or word item. If you have any question about the Azure DevOps, then you can refer to the docs.microsoft.com. That's all for my presentation.